Section 6.8 is all word problems. Really, they come in two types. The first type that we're doing deals with throwing objects into the air, or dolphins jumping, or men diving. All of them have to do with a vertical height that we're worried about, and all of them have this key number, negative 16t squared in them. So you're going to see that negative 16t squared come up in each of these problems. The reason that it's a key number is because these are trying to keep realistic problems, and in reality, the force of gravity impacts any of these situations at an actual rate of 16 feet per second squared. So anytime that this negative 16 enters a formula, you know that it's really representing gravity and that force pulling something back down. When we look at problem number 1, it says an object has been thrown straight up into the air. The formula h equals vt minus 16t squared gives the height h of the object after t seconds, when it is thrown upwards with velocity v. After how many seconds will the object hit the ground if it is thrown with a velocity of 144 feet per second? So in this case, we want to plug into the formula h equals vt minus 16t squared, the variable h for the height that we want it to reach, and the variable v for the velocity we're initially throwing the object with. The h height is a little confusing to pull out of here. It really comes from this idea of the object hitting the ground. The height something is off the ground when it hits the ground is 0. So really, the fact that we're trying to find when the object hits the ground is what tells us we should plug in 0 where we see h in the formula. It then says that we're going to throw with an initial velocity of 144 feet per second. That means that 144 goes in where I see v. So this becomes 144t minus 16t squared. In general, I like to rearrange that so that we have the highest power of the variable first and the next highest next. So I would rewrite this as negative 16t squared times, or I'm sorry, not times, plus 144t. But we do want to write it as a factored form in order to find the answer. So the way that we're going to factor this is we're going to find the greatest common factor, which is negative 16t. I'm going to warn you that for pretty much all of these problems, you want to pull out a negative 16. There'll be times where you pull out a t because each of the terms has a t. There'll be times where you just pull out the negative 16. In this case, since the lowest power of the variable I see is the first power of t, I'm going to pull out the t with the negative 16. What's then going to be left behind is negative 16t squared divided by negative 16t. Those negative 16s will go away and I'll be left with t squared over t, which is really t to the second over t to the first. Using my division rule, 2 minus 1 just leaves me with t to the first. When I divide 144t by negative 16t, the t divided by t will make the t's go away. Since this is a positive being divided by a negative, my answer will be negative. And then I can put into my calculator 144 divided by 16. If I did that, it would tell me an answer of 9. So I should be getting a negative 9 here. The way I should read this is that I have two factors being multiplied, negative 16t and t minus 9. I'm looking for a value of t that would make either one of these 0. So really, there's two possible answers here. First answer comes from setting negative 16t equal to 0. That's the outside factor. If I then divide each side by negative 16, that would tell me that t equals 0 over negative 16, which is just 0. That is a correct answer for when the object's on the ground, but only because that's where it was before I threw it. They really want us to know when does it go up and then come back down and hit the ground. So in order to find that answer, I need to look at this second factor, t minus 9. If I set this second factor, t minus 9, equal to 0, I need to move this 9 to the other side by adding 9. So I would get a final answer of t equals 9. What that's telling me is if I throw it up in the air at a velocity of 144 feet per second, it's going to hit the ground 9 seconds later. In problem 2, we're told the height h in feet reached by a dolphin t seconds after breaking the surface of the water is given by h equals negative 16t squared plus 64t. How long will it take the dolphin to jump out of the water and touch the trainer's hand when h equals 64 feet? So in this case, we're given a height that is not 0. We're not trying to find when it reaches the ground. The dolphin's going to jump up and reach a height where it touches a trainer's hand. So in our formula, h equals vt minus 16t squared, which has been given to us as h equals negative 16t squared plus 64t, we're first going to plug in for h, saying that that's equal to 64. Everything else is given to us. Negative 16t squared represents the gravity, and then the plus 64t tells us that the initial velocity was 64. Unlike the problem above where we could start factoring because we had 0 equals, we need to move this 64 before we can begin factoring. So if it's a positive 64 on the left-hand side of the equation, by subtracting 64 from each side, we're going to get something in terms of 0 equals, now negative 16t squared plus 64t minus 64. Again, the key number is negative 16. For all of these problems, you're going to take out a negative 16 when you go to factor. In this case, since I have a term that has no t's, I can't take out a t with it. So I need to take out just negative 16. When I do that, negative 16t squared divided by negative 16 leaves me with t squared. Positive 64t divided by negative 64, divided by negative 16 gives me negative 4t. And finally, negative 64 divided by negative 16 gives me positive 4. This is all still equal to 0. So what I see is I now have a trinomial to factor. Ideally, you'd recognize this as a perfect square trinomial, where it's really the middle term, negative 4. If I divide it in 2, we get negative 2. If I squared it, I get to 4. So I can see that this negative 16 still stays outside, but this just becomes t minus 2 quantity squared. Another way of writing this would be t minus 2 times t minus 2. There's no way to make this negative 16 0, meaning it's not a factor I have to worry about. To make this t minus 2 equal to 0, I'd have to put in a positive 2. What that's telling me is after 2 seconds, the dolphin jumps to a height of 64 feet. So again, I could do it out the way that I did up here and say, well, let me take the factor I want to equal 0, t minus 2, set it equal to 0. If I then added 2, that's how I would get t equals 2 seconds as my answer. For the final problem of this type, men are diving from a cliff to the water 1,600 feet below. A diver's height, h, in feet above the water t seconds after diving, is given by h equals negative 16t squared plus 1,600. How long does a dive last? To be clear, I altered this problem from the one in set gauge. I highly doubt any human is jumping from 1,600 feet. Please don't try it. That said, pretend that this was a real situation. If I'm looking for them to get to the water is 1,600 feet below where I start. So I start plus 1,600 above the water. I don't have any initial velocity here. I'm just jumping, so I'm not jumping 100 feet per second in the air. I'm basically letting myself fall. That's why there's no t term here. But in the end, we really want to get to 0 as our height. We want to be in the water. That's why I set this up as 0 equals negative 16 t squared plus 1,600. Next step, since I already have it set equal to 0, is to pull out that negative 16. Since this has a t squared and this has no power of t, I can't pull out a t with it. When I divide negative 16t squared by negative 16, I just get t squared. When I divide positive 1,600 by negative 16, I should get negative 100. Hopefully you can then recognize this as a difference of squares. Difference of squares, meaning I have something squared, the minus sign, something else squared. The square root of t squared is just t. The square root of 100 is 10. So I have t and 10 in the two positions, one with a plus, one with a minus. If I now set each of these parts that are being multiplied equal to 0 to see how to make it 0, there's nothing I can plug into t that makes negative 16 0. If I plug in a negative 10 here, it would make this factor 0, but I gotta think in context, what would negative 10 even mean here? That would be 10 seconds before the person jumped, which really means that the formula doesn't apply to them then. The formula only really starts working at time equals 0, or technically really after time 0. So, for that reason, even though this would give me an answer of negative 10, I can rule out that answer as not being logical within the confines of the problem. As opposed to this t minus 10 answer. In this case, putting a positive 10 in would give me 10 minus 10 equals 0. It is a reasonable answer to say that if they jump from 1,600 feet, they'll hit the water 10 seconds later. That's why t equals positive 10 seconds is the correct answer to this problem. Second type of word problem that we have to deal with these quadratic applications is one involving length and width. The larger formula that we're going to be working with is a formula you get in geometry, which is that the area of a rectangle equals the length times the width. So when I get a question like a table is rectangular and its length is 3 times its width, first thing I do is I set variables for length and width. So length, width. In this case, if the length is 3 times its width, let's set the width at x. That means the length is 3 times that, or 3x. Find the dimensions of the table. Just to be clear, dimensions means find the length and find the width. If it occupies 48 square feet of table space. So when it says what it occupies, this 48 square feet that it occupies is the area. I'm going to put it in where I see an A in my formula. Next thing that I'm going to do is plug in for the length what I have it equal to in variable terms, 3x. I'm then going to plug in for the width what I have it in variable terms, x. Next step, I'm going to keep that 48. When I multiply 3x times x, there's an understood 1 here, so 3 times 1 still gives me 3. X to the first times x to the first. You add the powers, 1 plus 1 gives me x to the second. What I would now do is subtract 48 from each side, minus 48 here, minus 48 here. That would give me 0 equals 3x squared minus 48. I can take the common factor 3 out of both things. When I do that, 3 comes out front. 3x squared divided by 3 just gives me x squared. And negative 48 divided by 3 would give me negative 16. That means that this becomes a difference of squares problem. X squared minus 16 can be written as x plus 4, x minus 4. If I now think about what can make each of these terms that are being multiplied 0 and what makes realistic sense in the problem, well, there's no way to make 3 0, so I can ignore that term. X plus 4, the way to make that 0, if I set it equal to 0, I would subtract 4 from each side and get x equals negative 4. But in the context of the problem, it doesn't really make sense for something to be negative 4 feet. The shortest something can be, if it didn't exist at all, would be 0 feet. So for that reason, this negative 4 isn't really a logical answer in context, and I can throw it out. As opposed to the positive 4 that I'd get from this term. If I took x minus 4 and set that equal to 0, then adding 4 to each side would get me to an answer of x equals 4. X equals 4 is the correct answer here. It represents the width of the table. If the table occupies 48 feet squared, then my width of my table should be 4 feet. If I want to find the length of my table, I take that answer 4 and I multiply it by 3. 3 times 4 would give me 12. 12 feet would be the length of the rectangular table. If I wanted to check to make sure that I had the correct answers, I could multiply 12 feet by 4 feet. 12 times 4 would give me 48. 48 square feet is supposed to be the dimensions of the table. In problem 5, it's the same general setup. We're trying to get to this A equals LW formula. The difference is when we're given the information about the length and width, instead of being a multiple 3 times as large, here it's additive. The length is 4 inches longer. So what that means is when we go to set variables for length and width, we can still make the width x, but if we want to say 4 inches longer for the length, we need to call that x plus 4, not x times 4. We now have a length and a width in variable form where there's only going to be one variable to solve for. We can look at the formula and see where it tells us the area of the rectangle is 32. Plug that into my A equals LW formula. So A, 32, equals L, x plus 4, times W, x. If I multiply out this right side, the left side would still be 32. On the right, x times x gives me x squared. 4 times x gives me plus 4x. I can then subtract 32 from each side. On the left, that just gives me 0. On the right, since it has nothing to combine with that's a like term, I can leave it as x squared plus 4x minus 32. I now have 0 equals x squared plus 4x minus 32 that I need to factor. So I always do it as 2 parentheses, x and x. I bring down the first sign, positive. Second sign tells me same or different. Different from a positive sign is a negative sign. I'm now looking for 2 numbers that multiply to 32 and subtract to 4. Well, the ways to multiply to 32 are 1, 32, 2, 16, and 4, 8. 32 minus 1 would give me 31. 16 minus 2 would give me 14. And 8 minus 4 would give me 4. The one I'm looking for is 8 and 4. So I put the larger one here, the smaller one here. What I now need to do is figure out what can I put in for x to make this statement true where it would be equal to 0. For this set of parentheses, putting in a negative 8 would give me negative 8 plus 8 equals 0. But again, it doesn't really make logical sense to have something that's a length of negative 8. So I look to this factor. X minus 4, what would make that 0 is a positive 4. What that tells me is that the width equals 4 inches. But I didn't want the width. They wanted me to find the length. So to find the length, I can plug this in and say the length is 4 plus 4. 4 plus 4 equals 8 inches. So I can put here that the answer for the length is 8 inches.